Hi everybody, let us see the wave equations of electromagnetic waves in this lecture. In general, electromagnetic waves will be the carrier of energy or information. And it is a function of both space as well as time. The electric and magnetic fields present in electromagnetic waves will vary with respect to time and spatial coordinates. Actually, the Maxwell's equations prove the existence of electromagnetic waves. Actually, the existence of electromagnetic waves are really predicted by Maxwell's equations, and it was formulated through a well-known Maxwell's equations. Hertz experimentally proved that Maxwell's predictions of electromagnetic wave was really true, and he also succeeded in the generation and deduction of radio waves. So the contribution goes to Hertz also at this moment. So the study of wave behavior in any medium is the major focus in this video lecture. Let us see how to derive the equations, wave equations, in this particular lecture. Let us start discussing about EM wave equations in generalized form from Maxwell's equations under time varying conditions, time varying electric and magnetic fields with respect to space as well as time also. Right? Very good. So let us see, let us consider a medium with a linear, homogeneous, isotropic in nature. Actually, we are planning to derive the generalized wave equations. Let us assume that the electric and magnetic fields are present in a linear, homogeneous, isotropic and charge free medium where the rho v is considered to be equal to 0, with permeability mu, permittivity epsilon and conductivity sigma. Okay, and we also assume the medium obeys the Ohm's law. Point form of Ohm's law in electromagnetics states that J is equal to sigma E. J is equal to sigma E. It is an important relationship that we must remember. Let me start with the Maxwell's equations. Del cross E is equal to minus dou B by dou T. You all know very clearly. But what is B? B is equal to mu H. So obviously this equation can be modified into minus mu into dou H divided by dou T. So the first equation of Maxwell's is rewritten in a comfortable format. And you know that the Maxwell has made a change in the Ampere circuital law and included the displacement current density term in the equation. So originally it was del cross H is equal to J in magnetostatics, but it was later on modified by Maxwell as del cross H is equal to JC, conduction current density plus displacement current density. So JC is equal to sigma into E, as you know. The other one is, what is JD? JD is, it is the rate of change of electric flux density with respect to time, dou D by dou T. But D is equal to epsilon into E. In any linear homogeneous isotropic medium, D is equal to epsilon into E. So JD can be rewritten as epsilon into rate of change of electric field density with respect to time. It's one of the important relationships. So based on which, when we include the term JC as well as JD in the Maxwell's second equation, we could find that del cross H becomes sigma E plus dou E, epsilon into dou E divided by dou T. Epsilon into dou E divided by dou T is the second equation. The other one is, as you know, del dot B is equal to 0, but B is equal to mu H. So I will write this as del dot mu H is equal to 0. But you know, mu is a scalar So obviously the final expression is del dot H is equal to 0. It's one of the Maxwell's equations we must remember. Similarly, del dot D is equal to 0 is one of the Maxwell's equations, but we know D is equal to epsilon into E. So obviously del dot D becomes del dot epsilon into E. So it can be written as, because epsilon is a scalar, so this can be written as del dot E is equal to 0. It's also one of the important relationships that we must remember for the derivation of wave equations. Keep all these equations ready. Let me start with the derivation of electromagnetic wave equations in phasor format. Let me apply curl on both the sides of equation number 1. What is equation number 1? Maxwell's equation number 1. Del cross E is equal to minus mu into dou H divided by dou T. So when we apply curl on both the sides, del cross, so this will become, or this can be modified as minus mu into dou by dou T of del cross H. Okay, so this scalar mu, negative sign can all be taken outside. Even dou by dou T can also be taken outside, whereas the del cross curl operation will be applied only on the vector H. So it can be finally rewritten as del cross E is equal to minus mu into dou by dou T of right, del cross H. Once again I will write it and give equation number. Let me proceed with the equation derivation. Let me start with this. Del cross E is equal to minus mu into dou by dou T of del cross H. But you know, in one of the Maxwell's equations we have seen just before few seconds that del cross H is equal to sigma E plus epsilon into dou E divided by dou T. So when we substitute del cross H into this equation, we'll come to know that this expression can be reduced into minus mu into dou by dou T of yes, sigma E plus epsilon into dou E divided by dou T. Correct? Okay. So finally when we expand this, del cross E will become minus mu sigma into dou E by dou T minus mu epsilon into dou squared E divided by dou T squared. Did you notice one thing? Del cross E, according to vector identities, what we have learned in vector algebra, this can be rewritten as del of del dot E minus del squared E. Right? Okay. So but I have told you before few seconds that del dot E is equal to 0. Isn't it? Del dot E is equal to 0. One of the observations from Maxwell's equations. So this can be reduced into del cross E is equal to minus del squared E as del dot E is equal to 0. Okay. Let me move on to the next one. So del cross E is equal to, finally it becomes minus del squared E in this case. Del squared is a Laplacian operator which will become dou squared divided by dou x squared plus dou squared divided by dou y squared plus dou squared divided by dou x z squared in rectangular coordinate system of E. So we can, in general, we can rewrite this as minus del squared E is equal to minus mu sigma dou E divided by dou T minus mu epsilon dou squared E divided by dou T squared. So del squared E can be written as mu sigma dou E divided by dou T plus mu epsilon into dou squared E divided by dou T squared. Right. The above equation is a general equation, wave equation for electric field. It can be decomposed into three one-dimensional homogeneous scalar wave equations for three components, Ex, Ey, Ez. For those three components I can write individually because it was a general expression, del squared E, right? It is a general expression for general wave equation for electric field intensity. So the solution of each component of E represents a wave, in fact. Right. Let me identify the phasor form of this wave equation by replacing dou by dou T by j omega. Dou by dou T is equal to j omega. If I replace it, then this equation will become j omega into E. Yes. Similarly, the second term also in the equation will become j omega square. So this will be finally rewritten as j omega. If you simplify this, you will find out j omega mu into sigma plus j omega epsilon, right, multiplied by the vector E, del squared E. Laplacian of electric field intensity becomes j omega mu multiplied by sigma plus j omega E. Yes, let us imagine that this term j omega mu, what is it, j omega mu into sigma plus j omega epsilon as a new operator gamma squared. Then this equation will become, right, what is it, gamma squared E, by just assuming that this is equal to gamma squared. So what is gamma? Gamma is called as propagation constant. It is called as propagation constant. We may have to speak about this a lot in future, which comprises of alpha and beta, the wave parameters. We will discuss about this elaborately. Okay, so let me identify what is del squared E minus gamma squared E. It becomes simply 0. So let me write the phasor format of the electromagnetic wave equation for electric field is equal to gamma del squared E is equal minus gamma squared E is equal to 0. It's an equation to be remembered forever for understanding the behavior of electromagnetic waves in any medium. Particularly in our case, we have taken linear, homogeneous, isotropic medium with source free where rho v is equal to 0, and we have considered that the medium has got permeability is equal to mu and permittivity is equal to epsilon and conductivity is equal to sigma. So this is one of the wave equations. Let us derive the wave equation for H, magnetic fields, separately, magnetic field intensity. It can be obtained by taking curl as usual on both the sides of the Maxwell's second equation. So when we apply curl on both the sides, it will become del cross H is equal to del cross, right, sigma E plus epsilon into dou E divided by dou T. So what will be the effect, impact on it? Let us discuss about it. So del cross, yes, sigma is a scalar. I can take it as a common factor. So this will become del cross E, the first factor of first term in this equation, whereas the second term epsilon is a scalar. So obvious, and dou by dou T can also be treated outside, whereas the del cross curl operation is applied only on electric field intensity. So we will find out that this equation reduces to this format. But we know what is del cross E. Before few seconds in one of the Maxwell's equations, we have seen that it is mu dou H divided by dou T. If possible, try to substitute into this relationship. You will find out that this will become an interesting equation, because del cross H is equal to sigma into del cross E can be converted into sigma into minus mu dou H divided by dou T. Yes, epsilon into minus mu dou H divided by dou T. So the equation can be finally expressed as minus mu sigma dou H divided by dou T. Yes, minus mu epsilon into dou squared H divided by dou T squared. I hope you would agree with me. But according to vector identities, del cross H is equal to del of del dot H minus del squared H. So as you know, del dot H is equal to 0 in one of the Maxwell's equations, because del dot B is equal to 0. When it is converted into H equation for H, so this becomes del dot H is equal to 0. When you substitute into this relationship, you will come to know that del cross H gets reduced to minus del squared H. Now you have two equations with you. One is about del cross H minus del squared H is equal to minus del squared H, whereas del cross H is equal to, in this format also an equation is available. So let me equate both the sides, and we will say it will become del squared H. So this will become minus del squared H is equal to minus mu sigma dou H divided by dou T minus mu epsilon dou squared H divided by dou T squared. So finally this equation can be represented as del squared H is equal to mu sigma dou H divided by dou T, yes, plus mu epsilon dou squared H divided by dou T squared. Okay, it's a general wave equation for magnetic field intensity. It can be decomposed into three components, three one-dimensional homogeneous scalar wave equations, and the solutions of each component of H represents waves. And we can definitely replace dou by dou T by j omega. So this equation will get reduced into j omega mu, as it was in the earlier case, sigma plus j omega epsilon. So this can be rewritten as del squared minus gamma squared H is equal to 0, where gamma is equal to, what is gamma squared? Gamma is a propagation constant. Gamma squared is assumed to be equal to minus j omega mu into sigma plus j omega epsilon, right? Gamma is a propagation constant. So this equation, del squared H minus gamma squared H is equal to 0, and one more, del squared E minus gamma squared E is equal to 0, are called as generalized wave equations for electromagnetic waves in a linear isotropic homogeneous medium with charge free conditions where permeability is mu and permittivity is epsilon and conductivity is sigma. They are also called as vector Helmholtz equations. Thank you so much.